Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 Chemistry class. You are welcome for today's lesson. Today we are on Unit 1, which is carbon and its inorganic compounds. Carbon and its inorganic compounds. So you remember we had started this unit in the previous lessons. We had talked about carbon, we had talked about allotropes of carbon. So today we are going to talk about the chemical properties of carbon, all right? Chemical properties of carbon. So to remind you, you remember carbon is in group 7. It has atomic number 6. Atomic number 6. So carbon is in a periodic table like other elements of the periodic table. It has atomic number of 6, electronic configuration 2 and 4. So today we're going to look at its chemical properties, all right? Chemical properties of carbon. So everybody there, take your pen, take your book, and we start with the lesson. Are you ready? All right. As we said, you remember, I always tell you that when we talk of the chemical properties, we refer to reactions, all right? So when we talk of the physical properties, you remember we had talked about physical properties of some of the allotropes of carbon. So when we talk of the physical properties of any element or of anything, we refer to the makeup, the structure, the appearance of that substance, all right? But when we come to the chemical properties, we expect some reactions. Reaction of that element or that substance with other elements or compounds, all right? So today, as I said earlier, that we're going to look at the chemical properties of carbon. So we start by looking at the reaction of carbon with oxygen, all right? How does carbon react with oxygen? This is burning charcoal in oxygen, all right? Burning charcoal in oxygen. So charcoal was put in a gas jar that contains oxygen, so it continued to burn. It continued to burn. So when I talk of charcoal, that is carbon. You remember among the allotropes of carbon, charcoal is inclusive, the amorphous carbon, all right? So when you introduce or when you put in a gas jar burning charcoal, it continues to burn, not until it becomes excess of oxygen, all right? So let's look at that the charcoal continues to burn in gas jar even after heating has stopped, all right? What does it mean? When you get charcoal, you put it, you heat charcoal in a gas jar and you stop heating. It will continue to burn in oxygen, all right? That is the production. What is produced there? What is produced there? When you get charcoal, that is carbon, plus oxygen, or in oxygen, that is carbon dioxide that is formed, all right? Burning charcoal, look at the screen there, all right? This equation here. This carbon is from charcoal. Charcoal, it is a form of carbon. Plus oxygen, carbon dioxide is formed. How do you know it's carbon dioxide that is formed? It's carbon dioxide that is formed. We test this by introducing it or by introducing it, that gas, into lime water. That is calcium hydroxide. All right? So when you get carbon, right, carbon plus oxygen, you get carbon dioxide, gas, this is solid, plus some heat. It is exothermic reaction, all right? So how do you know that this gas produces carbon dioxide? All right? So you react this gas that is formed with calcium hydroxide. Normally we know that calcium hydroxide is the confirmatory test for carbon dioxide. How? So get carbon dioxide plus calcium hydroxide. This is calcium hydroxide, aqueous, right? Plus carbon dioxide, gas. We get calcium carbonate. This is solid plus water, which is a liquid. So the formation of calcium carbonate, this is a white precipitate, white PPT. In other words, sometimes we say milky. All right? So the formation of calcium carbonate confirms that, or when you react and you see there is a white precipitate, normally calcium hydroxide is colorless, all right? Colorless. So when it reacts with carbon dioxide and you see that it has a tender milk color or a white precipitate, you confirm this is carbon dioxide gas that has been formed. Why? Because when we react calcium hydroxide, that is colorless, with carbon dioxide, we expect to form calcium carbonate, which is a white precipitate. So when you form other colors, or when the colorless remains, you don't confirm this gas is carbon dioxide. So whenever we react carbon with oxygen, we get carbon dioxide gas. And this carbon dioxide is confirmed when you react it or when you introduce it into calcium hydroxide, which is colorless, and finally you see a white precipitate being formed. All right? That is the confirmatory test for carbon dioxide gas. Now, when you continue to put in or introduce in excess carbon dioxide, that is, you have this now, right? You have this calcium carbonate plus water. Then you continue to put in carbon dioxide, calcium carbonate, all right, solid, plus water, what we have there, liquid. Then you continue putting more of carbon dioxide gas. Some changes will take place. We shall form calcium hydrogen carbonate, calcium hydrogen carbonate, all right? And this calcium hydrogen carbonate, which is aqueous, it is colorless, all right? What does it mean? So in your practicals, you're trying to attempt this, you get calcium hydroxide, introducing carbon dioxide, you see a white precipitate being formed, all right? But when you continue to bubble in or to introduce in more of carbon dioxide, that white precipitate or that milky color will disappear and be colorless. And you see the substance becoming colorless again. That's why normally you are advised, when you're doing a practical, your eye should always be on what you're doing. Because some of you will be working as you are murmuring around, and when you turn, you say that there is no change that has taken place because there is this white precipitate that came in and has disappeared to go back to a colorless or to the formation of calcium hydrogen carbonate, which is also colorless like the calcium hydroxide. Then you say, you know what, teacher? There was no color change. It remained colorless, yet you were just looking up and down. So you need to be attentive wherever you are doing a practical work. That's why in Senior 1, you study some laboratory rules and regulations, that you need to be smart and neat and very attentive in whatever you're doing. All right? Good. So that is carbon plus oxygen forming carbon dioxide, and we confirm it is carbon dioxide by introducing it into liquid or something which is colorless, and that is calcium hydroxide. then we say a color changing to a white precipitate or a milky color. All right? Good. And when there is continuous introduction of carbon dioxide, here you will see that the white precipitate will disappear and a colorless solution is again formed. Right? Good. That is under complete combustion. Complete combustion. Complete combustion, it means what? It means that the carbon has reacted with enough oxygen. But there are times when there is limited oxygen. Carbon reacting with limited oxygen. Like the other time we were talking about how charcoal is made. No, I told you of covering the pores, introducing limited oxygen. That is, we don't form carbon dioxide in that case, we form carbon monoxide. Right? CO only, without 2. That is carbon monoxide. As the equation you can see here on the slide there. There is a difference between carbon plus limited oxygen, you get carbon monoxide. Than this where we form carbon dioxide. This is when there is enough oxygen. And this is when there is limited oxygen. So in limited oxygen, we form carbon monoxide. In enough oxygen, we form carbon dioxide gas. All right? Think you get a difference there. Good. So, reaction with carbon dioxide. How does carbon dioxide react with carbon? All right? So when you get carbon dioxide and you pass it over heated charcoal, right? The charcoal diminishes. What does that mean? It means that carbon dioxide stops burning, does not support burning. So you see in fire extinguishers, they use this, there is carbon dioxide. If you see in those containers of the fire extinguishers, you will see carbon dioxide written on top there. What does it mean? It means that carbon dioxide is used to put down fire. Right? It is used as in fire extinguishing. So that's why when there is a burning charcoal, that is carbon, then you pass over carbon dioxide, you see that the fire will go off. So a gas that is produced with a blue flame, that is carbon monoxide. All right? Good. Now reaction with iron 3 oxide. Reaction with, whenever I say reaction with iron 3 oxide or with any other thing, I mean carbon reacting with iron 3 oxide. So this is charcoal. All right? This is charcoal with iron 3 oxide, charcoal black, iron 3 oxide red. There is some heating there. Basani burner, you can see. What takes place there? What happens? That's what we are going to see. So when a mixture of iron 3 oxide and powdered charcoal is heated, the red glow is produced. The glow continues spreading throughout the mixture even when heating is stopped, all right? So the color of the mixture turns from red-brown to gray color. What does that indicate? So when you're heating iron 3 with carbon, the carbon, look at the equation below there on the slide, please. So you see this is iron 3. This is an equation for iron 3 oxide. And this is carbon. So whenever you're hitting iron 3 oxide with powdered charcoal or with carbon, it means that it was red before. It was red-brown. So, and I said after the reaction, or after heating, you will form a gray color. What does it mean? It means that the iron 3, or the carbon reduced, the carbon reduced the iron 3 oxide to form or to oxidize itself to carbon dioxide. So the oxygen that was on iron 3 oxide was captured by oxygen, that is oxidation, to form carbon dioxide, as you can see from the slide there. See here, we had iron 3 with oxygen here, iron 3 oxide to a single carbon. Now this one remained as iron, and this becomes carbon dioxide, meaning that the carbon removed oxygen from iron 3 and added it on itself to form carbon dioxide. We call that one oxidation. What is oxidation? Addition of oxygen and removal of oxygen. That is reduction. Removal of oxygen, that is reduction. Addition of oxygen, that is oxidation. So carbon removed oxygen and added it on itself, that is oxidation, to form carbon dioxide. That's what happened. That's why the red-brown color here turns into a gray, because it is no longer iron 3 oxide, which is red-brown, but it is now iron, which is gray. All right? Good. So we can continue to look at some other reactions of carbon, how carbon reacts with concentrated sulfuric acid and nitric acid. These are stronger acids, right? Sulfuric acid and nitric acid are among the strongest acids that we have. All right? So how does carbon react with these strong acids? So whenever carbon reacts with concentrated sulfuric acid, this is what is formed. There is formation of carbon dioxide, sulfur dioxide, and water. So two gases are formed. That is carbon dioxide and sulfur dioxide gases, plus some amount of water. So look at the equations. Look at the equations there. Whenever we react carbon with sulfuric acid, we form carbon dioxide, sulfur dioxide, and water. All right? So, but for the case of nitric acid, when nitric acid reacts with, this is nitric acid. This is the equation. This is the formula for nitric acid. So whenever carbon reacts with nitric acid, all right, we form carbon dioxide, nitrogen dioxide, plus water. So these acids oxidize to carbon dioxide to form oxidize carbon to form carbon dioxide. It is carbon dioxide gas that turns lime water milky. That one I always tell you. How do you confirm that carbon dioxide is produced? It is confirmed when you react carbon dioxide with calcium hydroxide. So whenever calcium hydroxide reacts with carbon dioxide, we form calcium carbonate, which is white, a white precipitate. And we confirm there, this is, a milky state, as there, it is indicated there, a milky state. So you see the color of calcium hydroxide, which was colorless, becoming a white precipitate or a kind of a milky color. And there you confirm that the gas that was produced is carbon dioxide. All right? So it comes as a result of carbon oxidizing itself to form, or carbon removing the oxygen from either concentrated sulfuric acid or from nitric acid and adds it on itself, oxidizes it. So these acids will oxidize the carbon to form carbon dioxide gas, which will turn the lime water, that is calcium hydroxide. In fact, when you hear of lime water, calcium hydroxide, another name for calcium hydroxide is lime water. Can't talk of lime water, then you get confused. So calcium hydroxide, another name for calcium hydroxide, we call it lime water. All right? So I repeat this. The confirmatory test for carbon dioxide is to turn lime water, which is colorless, to a milky state or to a milky color or to a white precipitate. You can use the two words alternatively and say white precipitate or a milky color. That one can be asked in any exam. All right? Good. So this is a small exercise of which you have to do when you go back in your free time. So the first question. The first question reads, carbon reacts with carbon dioxide according to the equation. See the equation here? This is the equation. Carbon dioxide plus carbon form carbon monoxide. And we have looked at that in our explanations. So identify the substance that loses oxygen and the one that gains oxygen from the reaction above. So among these elements or these compounds here, these substances, carbon dioxide and carbon monoxide, then you have also carbon monoxide there. So which one loses oxygen and which one gains oxygen? That is the equation. And you have looked at that. All right? Good. The second question. Carbon reacts with oxygen according to the equation below. All right? So you remember I've looked at these equations. We have looked at these equations. The reaction of carbon with oxygen, the reaction of carbon with carbon dioxide. I can show you when we go back in what we have looked at. This is one of the two. So reaction of carbon with oxygen, right? This is what we have talked about, right? Reaction of oxygen with carbon, right? And then reaction of carbon with carbon dioxide. This is what is formed. We have talked about that. Not so? Any question there? So this is what we have talked about. Then the question comes, all right? Carbon reacts with oxygen to form the following equations here. Carbon plus oxygen, you get carbon dioxide. All right? Plus heat. Another way, there is carbon reacting with limited oxygen, as we said. Limited oxygen, remember. These two equations. Where carbon reacts with oxygen from carbon dioxide, this is when oxygen is in abundance. There is enough oxygen there, all right? We form carbon dioxide plus heat. Get that? But when there is a limited oxygen, carbon plus limited oxygen, sometimes we put half here, and we put half here, half oxygen, to form carbon monoxide plus heat, because it is an exothermic reaction, you remember that. Whenever you see this heat here, get to know some temperature or some heat is given off. It is exothermic reaction. Remember, I have exothermic reactions and endothermic reactions. So whenever you see there is this heat in any equation, in any reaction, get to know this reaction is exothermic, all right? There is production of heat. So go back to the question. Carbon reacts with oxygen according to the equations below. These are the equations they are talking about. Those are two equations. The formation of carbon dioxide and the formation of carbon monoxide. So question 1, what condition is required in Roman 1 and Roman 2? We have talked about that. Why is it that, in other words, why is it that in the first equation, we form carbon dioxide, and then last equation, we form carbon monoxide? I've talked about this several times. So what are those conditions that are needed? Another question on that same question, sub-question, sorry, on the same question, what does heat in the equations indicate about the two reactions? I've talked about that already. So I've said, whenever you see heat, what does it indicate? There are some equations where we don't see heat, putting heat there. So those where you see they put heat, production of heat here, what do we call this? What does it mean? All right? Good. So the last question is, write balanced chemical equations for the reactions that take place. So we looked at that. We looked at the reaction of concentrated sulfuric acid and nitric acid with carbon. All right, we looked at that, you see. So you're going to write the equation, a balanced chemical equation. See, normally when we talk of a chemical equation in chemistry, you need to write the symbols very well. You need to indicate the states. Mainly three things. To write the symbols very well, all right? After writing the symbols very well, you need to show the states of matter in which they exist in each case. Then finally, you need to balance the equation. That's the well-written chemical equation. All right? So you should write the equation, balance it then. Roman 1. Carbon reacts with concentrated nitric acid. So write a well-balanced chemical equation where carbon reacts with concentrated nitric acid, as we have learned in our work here, in the lesson. Lastly, you will write a well-balanced chemical equation between carbon and concentrated sulfuric acid. So those are the three small questions that you need to work on in your free time. I have seen that each and everything there, we have talked about it. So go and try to do those questions. Then when you come back, I will try to see how to pass through them when we are together here in class. All right? So I think everybody will be able to attempt those three questions. Do you have any question there? So if there is no question, try to do them. Then, as I said, when we meet here, we shall try to collect them together. So thank you so much for your good attention. Let's meet in the next lesson next time. Bye.